Okay, hi everybody. So today we're going to go ahead and go through 9 through 13 of the data graphs out of the packet. So let's just jump right into it. Okay, so what we have here is we have let g be a piecewise linear function defined from -2 pi to 4 pi, whose graphs is given above. Let g of x be equal to g of x minus cosine of x over 2. Find the integral from -2 pi to 4 pi of f of x dx. Show the computation that leads to the answer. Okay, so I'll just go ahead and place this right in for the integral here. So when I do so, I have the integral from -2 pi to 4 pi of f of x, but f of x is g of x minus cosine of x all over 2 dx. Okay, by the linearity of this, so linearity means you're able to pass it through. This is equal to the integral from -2 pi to 4 pi of g of x minus the integral dx, sorry, minus the integral from -2 pi to 4 pi of cosine of x all over 2 dx. Okay, so now I just have to integrate these. Okay, this is pretty simple. This is just actually integrating cosine. This one over here is a little bit different, but we actually know what the graph of g of x looks like. It looks like this up here. So I can go ahead and just use the area under the curve to evaluate from -2 pi to 4 pi. Okay, so in doing so, this is a triangle. So I'm going to go ahead and go up here. So the formula for the area of a triangle is area is equal to 1/2 the base times the height. So area is equal to 1/2 the base. Now the base is the distance from there to there. So from there to there is 4 pi, from there to there is 2 pi. So the base is going to be 6 pi, and then times the height, and the height is 2 pi. The 2's cancel, so I'm left with 6 pi squared. Kind of a weird thing. Okay, pi squared. Okay, so anyway, so that's what the integral of g of x is from -2 pi to 4 pi. So I have 6 pi squared, and then minus the integral of cosine. So the integral of cosine is sine, a positive sign. So I'm going to have sine of x all over 2. But by the reverse chain rule, you have to divide through by the derivative of what this is, which is 1/2. So you flip and you multiply, and you get a 2 there. And we do have to evaluate this from -2 pi to 4 pi. Okay, so then this is going to be equal to 6 pi squared minus 2. And then I'm going to go ahead and just write this all in brackets now. So I'm going to have sine of x over 2. So 4 pi over 2 is 2 pi. So this is sine of 2 pi minus, plug in the -2 pi over here. So the 2's are going to cancel. You just have -2 pi. So I have sine of -pi. Okay, now hopefully you recognize sine of 2 pi is just simply 0. Sine of -pi is also 0. So this just gives me 6 pi squared. And that is my answer. Okay, B. Okay, find all the values in the open interval from -2 pi to 4 pi for which the f has a critical point. What does a critical point mean? It means the derivative of f, because we're on an f, is equal to 0. So that's what I'm looking for. Okay, so let's go ahead and go back here, and let's rewrite this equation. The g of x minus cosine of x over 2. So I have f of x is equal to g of x minus cosine of x over 2. So taking the derivative here, I'm going to have f prime of x is equal to g prime of x. Now the derivative of cosine is negative sign, so this is minus the negative. So plus sine of x over 2, but by the chain rule, I need to multiply by the derivative of x over 2, which is 1/2. So I have that. Okay, now what I need to do is I need to figure out, okay, where is this thing equal to 0 at? So 0 is equal to g prime of x plus 1/2 sine of x all over 2. Okay, and this is kind of a tricky one. How in the world are you supposed to determine what this when you don't even know what g prime is? Well, actually, maybe I do know what g prime is, because we know what the graph of g of x looks like. Okay, the graph of g of x looks like this. So g prime is just the slope of the tangent line. So if you notice from -2 pi to 2 pi, the slope here is equal to 1. So m is equal to 1. And then going from here to there, the other part of g, it's going to go down 2 pi over 4 pi. So the slope here is -1/2. So I actually do know what it is. So I can come back here and I can basically write this up in two different ways, okay? So one of them is going to be 0 is equal to 1 plus 1/2 sine of x all over 2. And this is the case when x is between -2 pi and 0, okay? But then I also know I'm also going to have 0 is equal to the other slope, which was -1/2 plus 1/2 sine of x all over 2. Okay, and this is when x was between, what was it, 0 is less than x, which is less than 4 pi, I think, is what it was. Let me check. Yep, 4 pi. Okay, so going back over here. Okay, so what I want to know is what's the value of x that's going to make this equal to 0? It's not. Okay, why is that? Because in order for it to be equal to 0, this whole entire thing has to be equal to -1, right? But sine of x, the biggest or smallest it can be is positive or -1. So the smallest it can be is -1, which means the smallest this whole entire thing can be is -1/2. This thing can never be negative. Okay, so in other words, this gives us no information. Now, if you don't see that, there's another way you can do this. Subtract the 1. So I have 1/2 sine of x all over 2, multiply by 2. So -2 is equal to sine of x over 2. That's impossible. Sine's always between 1 and -1. Okay, that gives us no information. Can't be equal to 0. Okay, so go ahead and go over here. So then going over here, we'll go ahead and solve this just like normal. So I'm going to add it over. So 1/2 is equal to 1/2 sine of x all over 2. So 1 is equal to sine of x all over 2. Well, hey, look, now I just need to know where sine is equal to x over 2. We know that's pi halves. So I have pi halves is equal to x over 2. So x is equal to pi. That is my only critical value. Okay, C. So I want to evaluate the derivative at -pi over 3. So I'm going to take h prime of x is equal to, so I'm taking the derivative of the integral, which is the second fundamental theorem of calculus. So taking the derivative here, what do? You plug in the 3x. So I'm going to go g of 3x. But by the chain rule, you need to multiply by the derivative of 3x, which is just 3. And then minus, you plug in the 0, but then you multiply by the derivative of 0, which is 0. So I'm not even going to write it down. So I just have this. So I have h prime of -pi all over 3 is equal to 3 times g of 3 times -pi over 3 is just -pi. And now I just need to go back to the graph of g of x. So g of x is right here. Pi is going to be whatever y value that is. Now, I think some of you guys can realize that that is pi. If you don't see that, what I'm going to do is I'm going to create the equation of this line. And the equation of the line is y is equal to the slope. I'm going to put it in slope-intercept form. The slope is 1. So I have x, mx, so 1x, plus b, the y-intercept is 2 pi. And then I want to evaluate it at -pi. So -pi plus 2 pi gives me y is equal to pi. Okay, so what is g of -pi? It's pi. So 3 times pi is my answer. Okay, number 10. Okay, so the function g is defined on the closed interval from -7 to 5 and satisfies g of 0 is equal to 5. The graph y is equal to g prime of x, the derivative of g consists of a semicircle and 3 line segments as shown in the figure above. Find g of 3 and g of -2. It's asking you to find a point, and I bet you they gave you a point in there. If you take a look, they sure did. There is a point. So how do you find a point? Sorry, you're given a point, that's you to find a point. We're going to use the first fundamental theorem of calculus. Okay, so what do I know? I'm going to go from the lower bound, 0, up to the upper bound, 3. So 0 to 3 of g prime of x dx will be equal to g of 3 minus g of 0. So what is the integral from 0 to 3? Okay, well, I don't, or of g prime is from 0 to 3. I don't know exactly what the functions are, but what I do know is I have the slope below the curve. Sorry, the area below the curve. So I just need to find the area of this quarter circle and of this triangle. Okay, so the area of a circle is equal to pi r squared, but I'm only wanting a fourth of it, so I'm going to divide it by 4. Okay, the diameter, or sorry, the radius is 2, so 2 squared is 4. The area there is just pi. Okay, furthermore, I have to figure out what this is. Well, this has a base of 1, a height of 3, so 3 times 1 is 3, divided by 2, the area of this is 3 halves. Okay, so that means the area going from there to there is pi plus 3 halves. That's equal to g of 3 minus g of 0, which is 5. Add 5 to the other side, so I have pi plus 3 halves plus 5 is equal to g of 3. So g of 3 is equal to, so that's 10 halves. 10 halves plus 3 halves is 13 halves plus pi. And there's my answer. Okay. I still have to go forward and do the other part. So now I'm going to integrate from the lower bound, now negative 2, because negative 2 is less than 0, to 0 of g prime of x dx. And that's equal to g of 0 minus g of negative 2. So what is the integral from 0 to from negative 2 to 0? Negative 2 to 0, oh, that's just pi, is equal to g of 0, which I know is 5, minus g of negative 2. Sorry, I just want to make sure I'm telling you the right thing. So g prime of x, I'm going to go from negative 2 to 0. And so that's that to g of 0. Yeah, so I'm good. Okay, so subtracting it over. So I have pi minus 5 is equal to negative g of negative 2. So 5 minus pi is equal to g of negative 2. Okay, and that's the other one. Okay, B, find the point of inflection. Okay, so the point of y is equal to g of x. So to find the second, so to find the point of inflection, I need to determine where it switches concavities, and we know the second derivative determines that. So I have y double prime is equal to g double prime of x. So I just have to go up here and look at what g double prime of x is. Once again, I'm looking for it switches concavities, where the second derivative goes from negative to positive or positive to negative. So the second derivative is the derivative of the first derivative, right? The second derivative is the derivative of the first derivative. Okay, so this is the first derivative right here. So the second derivative is just simply going to be represented by the slope of the tangent line. So right from there to there, it's going to be positive, which means it's concave up. From there to there, it's going to be concave up because the slope of the tangent line is positive. From there to there, it's going to be negative. So it looks like we have a point of inflection at x is equal to 0. Okay, we'll go back and double check that in a second. Okay, then it goes from negative. Now the slope of the tangent line from 2 to 3 is going to be positive. So once again, it looks like I have a point of inflection at x is equal to 2. Okay, and then the slope of the tangent line there goes negative. So it also looks like I have a point of inflection at 3. Okay, the question is, I know that's where it switches signs or concavities, but is it truly a point of inflection? And the answer is yes. Okay, why is it so? So there's two things that have to happen in order for it to be a point of inflection. Okay, one of them is that it needs to switch concavities, but the second one is it has to be defined as a point. If there's no point there, it can't be a point of inflection. So the key here is what's in the instructions. The graph of g is defined on the closed interval from -7 to 5, which means that every point in there is defined, which means it exists. So x equals 0, x equals 2, and x equal to 3 are the points of inflection. And you can write POIs if you want to, of g of x, because this is where g of x switches concavities, and g of x is defined there. Okay, so there we are. Okay, next, the backside. Okay, so the function h is defined by h of x equal to g of x minus 1/2 x squared. Find the x coordinate of each critical point. Okay, so once again, h prime of x will be equal to 0 from -7 to 5, and classify each critical point as a minimum, relative maximum, or neither. Okay, so explain your reasoning. So I need to take the derivative here. So h prime of x is equal to g prime of x minus x, and I want to know where this is equal to 0. So I have x is equal to g prime of x. Now, how in the world do you figure out where that's the case? If you think about what happens here with this function, you're plugging in x and you're getting out x. That's essentially the same thing as the equation y is equal to x. It's just y is now g prime. So if I go back over here, where is the line of y is equal to x, or y is equal to g prime? Or x, g prime is equal to x. It's right here. Okay, that's what the equation is. So you know that there is going to be, the first derivative is equal to 0, and it's going to be equal to 0 at this location and this location. Well, that one's pretty easy. It's just simply 3. Okay, so x is equal to 3 is one of them. But what I know is I have another point over here. And it's the place where y is equal to x, essentially, because we have, it's g prime, crosses the graph of this circle. Okay, well, that circle is given as x squared plus y squared is equal to 4. 4 because the radius is 2. But at that point, y is equal to x. So this equation changes to x squared plus y squared, x squared plus x squared is equal to 4. Or 2x squared is equal to 4, so x squared is equal to 2. X is equal to plus or minus rad 2, but I'm only looking for the positive value because that's a place where it's positive. So, in other words, x is equal to the square root of 2 is another place where it has a critical point. Okay, so this and this are critical points of h of x, right? Okay, so now we have to determine what type of a critical point they are. So what I'm going to do is I'm going to take and I'm going to put these on a number line. The square root of 2 is smaller than 3 is. So I need to pick a value there, there, and there. Okay, so the easiest one here, I just have to make sure there's nothing funky going on. Like as long as I pick something on the left of here and there's no like weird changes or anything. So 0 would work because it's a nice, smooth, well-behaving function at that point. So I'm going to pick x is equal to 0 there. I'm going to pick x is equal to 2 there. Should go back and double check, make sure nothing's going on. It's weird there. Well, it is a little weird there, but I think that's okay. I can still point it there. And then I'm also going to pick x is equal to, we'll say 4 there. Okay, so I need to figure out what h prime of 0 is equal to. H prime of 0 is g prime of 0 minus 0. So this is just g prime of 0. G prime of 0, this is g prime, is 2. So we have 2. So this is a positive value. Okay, let's go through. Let's figure out what h prime of 2 is. That's g prime of 2 minus 2. So what is g prime of 2? Well, that's g prime. So g prime of 2 is 0. Right, it's right there. So I have h prime of 2 is equal to 0 minus 2, which gives me negative 2. So the derivative is negative on the interval. And then I pick 4. So if h prime of 4 is equal to g prime of 4 minus 4, which is equal to, now I'm not actually going to care what g prime of 4 is because it's going to require a little bit of work. I just want to know, is that going to be bigger or smaller than 4, right? Because that will tell me if it's going to be negative or positive. Okay, so if I go to g of 4, g prime of 4, so 1, 2, 3, 4, so it's going to be somewhere in there. And if I match it up with what the y value is going to be, it's going to be like right around 1. sorry. Once again, there's 4, and it's going to be right around 1. 1 is definitely less than 4. So here, this thing's going to be about 1 minus 4 is going to give you something that is less than 0. So it is negative there. So there's a relative max. Maximum at, actually I should state of what function, of h of x at x is equal to the square root of 2, because h prime of x goes from positive to negative at x is equal to the square root of 2. Okay? And at x is equal to 3, there is neither a min nor max because of h of x, because h prime of x goes from negative to negative at x is equal to 3. Oops, sorry, I'm like way off the page. Sorry, I didn't let you see any of that. Okay, so once again, x equal 3, there's neither a min nor a max because h prime of x goes from a negative to a negative at x is equal to 3. Period. Okay, and the last one. Okay, so let f be a twice differentiable function. So I'm able to take the derivative twice here. On the interval from negative 1.2 to 3.2 with h of 1 is equal to 2. First thing I think of is first fundamental theorem of calculus. They gave me a point, they're asking me to find a point. I don't know that. That's just like, that's what I'm thinking. Okay. The graph of f prime, the derivative of f is shown above. So this is the derivative. The graph of f prime crosses the x-axis at negative 1. It's right there. And x is equal to 3. So right there. And has a horizontal tangent line at x is equal to 2. So there's a relative minimum value there. Let g be the function of, given by g of x is equal to e to the f of x. Write an equation for the line tangent to the graph. So, like you always hear me say, what are the two things you need to know in order to come up with the equation of the tangent line? Okay, I need a point and I need a slope. So I first need to figure out what g of 1 is. Well, g of 1, by this definition right here, is equal to e of f of 1. Now, what is f of 1? Oh, it's 2. So this is e squared. So I have the point 1 e squared. Okay, then I need to know what the derivative is. So g prime of 1 is equal to, actually, let's do g prime of x first. Okay, so taking the derivative here, it's the e function, so it's my moon. We get e times f of x, but by the chain rule, you need to multiply it by the derivative of f of x, which is f prime of x. Okay, so then I plug in 1. So g prime of 1 is equal to e of f of 1 times f prime of 1. Well, what is e of f of 1? F of 1 is 2. So e squared times f prime of 1. Well, look, f prime of 1, here's the graph of f prime, is negative 4. So this is equal to negative 4e squared. Okay, so that is the slope. This right here is the point. So I just plug into the equation, y minus e squared is equal to negative 4e squared times x minus 1. Okay, and that's the equation. Okay. B, for negative 1.2, for x between negative 1.2 and 3.2, find all values of x which g has a local maximum. So how is it going to have a local maximum? To find that, I need to determine where g prime of x is equal to 0. So where do I have g prime? G prime was given by this equation right here. So I have 0 is equal to e times f of x times f prime of x. So you have two things that are being multiplied times each other, and the answer is 0. That means one of them has to be equal to 0. So either e to the f of x equals 0 or f prime of x equals 0. Now, if you think about this, it is impossible for e to the f of x to be equal to 0. You can't take e, raise it to a power, and have it be equal to 0. So in other words, this problem reduces to finding out where f prime of x is equal to 0. Well, lucky for us, we have a graph. of f prime of x. So it's equal to 0 at -1 and 3. So x is equal to -1 and x is equal to 3. Now I want to find a local maximum, so I need to know where the derivative goes from positive to negative. So where on this graph does it go from positive to negative? Well, I think I should go back and talk about that. What goes from positive to negative? And since I'm finding a local maximum of g, I need to determine where g prime of x is positive. That's what I want to know is where it goes from. Goes from positive to negative. That's what I need to know. So I need to know where does e times f to the f of x times f prime of x go from positive to negative. So I did it again. So e to any power is always going to be positive, right? Unless you put a negative out in front there, which is not. So this problem reduces to where is that going to be positive or negative? Okay, where is it going to go from positive to negative? I'm sorry. So if you go up here and you look at f prime of x goes from positive to negative there, and it goes from negative to positive there. So this right here is a relative maximum value. Okay, so there is a relative max value at x is equal to, we say -1, because max value of, we have to state what function we're talking about, g, because g prime of x goes from positive to negative there, or x is equal to -1. Okay, and that's it.
Okay, so let's go on to C. So in C, it says the second derivative of g is g prime of x is defined as this monstrosity of a thing. Is g double prime of -1 positive, negative, or 0? Justify your answer. Okay, so let's just go ahead and plug it in. So I have g double prime of -1 is equal to e of f of -1 times f prime of -1 squared plus f double prime of -1. Okay, so I just need to determine what these values are. Are they positive, negative, or so on? Okay, this right here we know is going to be positive. E raised to any power is always going to be positive, so I don't even need to worry about that. I'm just going to ignore it. Okay, now what is f prime of -1? If you go back to the graph, f prime of -1 turns out to be 0. So this is just 0. So it really just comes down to g double prime of -1 is equal to f double prime of -1. So is that going to be positive, negative, or 0? So what happens at -1? So the second derivative of f is just the first derivative of the derivative of f, right? So if this is the derivative of f, then f double prime is the slope of the tangent line of this graph. So at -1, you can see the slope is negative. So you know this is going to be less than 0. Okay, so it's less than 0. Let's see. G double prime of -1 is less than 0 because at this spot, and I should claim what it is, x equal to -1, the slope of f prime of x is negative. Okay, and there we are. Okay, so next one, D. Excuse me. Find the average rate of change of d prime. Now this is tricky. This actually got me the first time. Find the average rate of change of g prime. Well, what does that mean? That means the rate of change of g prime. Well, that's g double prime. So how do you find the average of anything? You add them all up and you divide by how much you have. Now this is tricky because we have something that's a continuous function, g double prime. So how do you add up an infinite amount of continuous data points? So what you're going to do is you're going to integrate it. Integral is the same thing as adding up. So I'm going to integrate all of g double prime of x, and I'm going to go from 1 to 3. Now that's adding them all up, but now I still need to divide through by how many I have. Now, you can't divide through by infinity, but instead here what you do is you divide by the interval from 1 to 3. So you divide by the length of from 1 to 3, which is 3 minus 1, which gives you 2. Okay, so this is equal to 1/2 by the first fundamental theorem of calculus, right here, the integral of g double prime of x. This is just going to be g prime of 3 minus g prime of 1. Okay, sorry. And then I need to go back and I need to figure out what these are. Okay, now where do I have these at? Okay, so let's see. Oops, wrong page. Okay, so g prime of 1, look. G prime of 1 is equal to negative 4e squared. Okay, so that's what this is. So minus 4e squared. Now what is g prime of 3? Okay, do we have that anywhere else? Well, it doesn't look like we have it anywhere else, but we do know the equation for g. G is given by this. So I can go ahead and use what g prime of 3 is equal to. Okay, so maybe I'll go over here. So g prime of x is equal to e to the f of x times f prime of x. So e to the f of x times f prime of x. So that's equal to, so g prime of 3 is equal to e f of 3 minus f prime of 3. Okay, so what are those equal to? So f of 3, where is f of 3 given? Where are you at, 3? Oh, duh. F prime of 3. This is f prime. F prime of 3 is 0, right? It's right on the graph. Sorry, I was looking for it in all my notes here. Okay, so that's just 0. So I have 0, and then 1/2 of this. So this gives you negative 2e squared, and that is the average rate of change. Okay, so that's all we have. Okay, thanks. See you next time.